All right, and we should be live. So, what's up, guys? I think I haven't. No, my door is closed. So, what's up, guys? Today we are gonna do our three questions of DSA like we do every single fucking day. I spend most of my day working through creating a YouTube clone like I was that day, but I figured that I can't do it live because there are a lot of secret link environment variables I can't share with you guys. Like there was this static URL that would have let you like I'm basically opening a web port on web server on my machine and exposing it to the public internet. And I don't feel comfortable doing that at all because you guys, I don't know, man, someone can attack my computer. So it's stuff like that, and then I had to create an environment variable that works in my package.json. So that was something. Basically, what I'm trying to say is there are a lot of variables I can't show you guys, and that's why I don't think I'll be able to stream me building YouTube. Other than that, we can definitely keep streaming. And Dave is in the chat. I want to turn this guy into a moderator. Can I do that? Pin message, add as a moderator, manage a moderator. Right, I made you moderator, Dave. You're the best. You're the fucking best. All right. And so let's start sharing the screen. What I did today was I also added a video description. So can you guys see that? Is there a video description that you guys can see? Dave, can you see the video description? I'm just closing all these whack ass tabs I have open because before I share my screen because it's a lot of weird stuff I shared. Right. Can close all of this and go right here. Right, and then we can share my screen with you guys. Start for free like I always do. I love free stuff. And I've got my bottle of water here today too. That's nice. The moment I start streaming, I get thirsty. It's weird. Stacks queues. Want to do something with stacks and queues. I feel like it. I feel like doing something with stacks and queues. Converter online. No, I want to do a question. Try it on GG practice. Right, you're given a string that represents the prefix form of a valid mathematical expression. So prefix is basically the operator before the operands. So if I open Excalibur right here, can I select all of them and delete them? Yes, I can. Right, so A plus B basically turns into plus A, B. And then operator precedence, yada, yada, yada. Let me just write that down. That's star and slash. And then there's plus minus. Right, that's it. Okay, you're given a string that represents the prefix form of a valid mathematical expression converted to its postfix form. So converting a prefix to postfix. Right. I'm going to convert this into AB plus. So if I've got a complex expression like star minus A star minus A and slash BC minus slash BC minus slash A minus, okay, it's star minus a slash bc minus slash a kl kl. Right, this is the prefix form. And prefix form, you start going from here. Right. I remember the prefix to infix conversion. You start from right to left, and what you do is basically the intuition is that the moment you get an operator, next two things are supposed to be treated as left and right. So it's a slash k, and put that in a bracket, and then L. Gonna underline that. Like I've converted that into an infix expression. And I encounter another minus, that's minus L, right? Increase this line, and then it's C B slash, so it's B slash C, and then A, and minus, so it's A minus, and then it's star right here. That means a star in the middle, and then I need to convert that into a postfix expression, right? So that means convert this into a minus b by c, all those brackets, yada yada yada. Um, a by k minus l star, convert these, a b by c minus a by kl minus, and then that is a b c slash minus a k slash l minus. Is that the answer? ABC slash minus akl minus, and then a star. Right. So that's the expression. And that's one way I can convert it into an infix expression and then convert that into a postfix expression. I think I should watch the video on stacks and queues, honestly. And there's a postfix to prefix conversion and a postfix to infix, convert infix to prefix notation. I think there's a very interesting concept because this emerged due to a concept of stacks and queues being used in programming language, and I forgot that base concept, and due to that I'm just not able to think in the right direction in these questions. So I'm gonna go watch this video.
Thank you, playlist, for starting off. Hey, everyone, welcome back to the channel. I hope you guys are doing extremely well. So the topic for today's lecture is arithmetic expressions. So we'll be reading about what is an operator, what an operand, the priority order. We'll be knowing about prefix, infix, postfix, arithmetic expressions. And once we know about it, we'll be doing conversions like infix to postfix, infix to prefix, and so on. So the first one is what is an operator and what is an operand. Let's understand what is an operator. So this is an operator. Now what is this? Whenever I say 2 to the power 3, usually you write something like this, 2 to the power 3, but if you have to write it in arithmetic expressions, you'll be writing it as 2 to the power 3. Agreed? The other one is the multiplication operator. Everyone knows that. Then there is a division operator. Then there is an addition operator. And then used for most of the arithmetic expressions. Okay, perfect. The first one is done. After that, we have having the maximum priority. So maybe we can is prefix, what is infix, and what is a postfix. So whenever you write mathematical expressions, you have to write recommending pre. All the operators will be pre. Mathematical are before the operand. What are the operand? These are the operand. Got it? What about the postfix? Again, as the name recommends, you have first this one, and after it, post it, you have the operators. Similarly, the operands over here, and then the operators. Again, how do you arrive at this? That is something we're going to do afterwards. But it's very important for you to understand what is postfix, what is prefix, what is infix operators. So you might have a question, infix. This is something that most of the programming languages understand, and we use infix heavily in C++, Java, and other programming languages. What about postfix? Now, these are used in stack-based calculators. Yes, these are used in stack-based calculators. So what about this prefix? Where is it used? It is used in a programming language extensively, which is known as Lisp. It is also used in tree data structures, right? But the most common one is infix one. Got it? So the first conversion that I will be doing is infix to postfix. As you can see that this is an infix expression. Why? Because the operators are between the operands. Got it? So what we will be doing is we'll be converting this into postfix. How? That's very simple. I'll be taking iterator I, which is going to be initially at the 0th index of the string. The infix expression is the string. I'll be taking a stack which is initially empty. I'll be taking the answer which is initially an empty string. I'll start by iterating at the 0th index. Now remember, if I see an operand, my stack still stays as it is because I don't put it into the stack and I add it to my answer. After that, I see a multiplication. Now this time I'm seeing a multiplication, which is an operator. If I'm seeing an operator, what I will do is I will look at the stack. What is greater? It's a answer. After that, I have a power operator. Now again, it's a power operator. After that, I have a D. So whenever the D comes in, I'll not be putting here. Now this negative sign has a lesser priority than what is there at the top. If that is the case, you pop this out. Yes, you pop this out and you add it to the answer. So once that is popped out, my bad. Once this is popped out, you look at the next top. Is the priority of opening bracket greater than this? No, it's not. So you don't pop it out. What you do is you simply say plus into this and you put that minus into the stack data structure and the answer stays as it is. After that, I go to the E. So whenever I go to the E, this time what will happen is, again, it is an operand, so the stack stays as it is. And you're going to do A, B, C, D, power, and then E goes over here. After that, I go to a closing bracket. Again, quite important. The moment you see a closing bracket, you just take out everything till you encounter an opening bracket. So the answer was A, B, C, E. So you pop out minus, you pop out opening, you got an opening, so you stop. You got an opening, so you stop. So basically you're at plus into, and the opening was out. So this is where you're at, and you don't push that closing bracket. Got it? Perfect. And this is where you will be like, okay, I'm done with the iteration. If you're done with the iteration, whatever is left on the stack, you can simply take it and pop it out first. Multiplied will be popped out, then a plus will be popped out. So this will be your postfix expression. Understood? If you didn't, while I write the code, you'll understand this in a very, very simple manner. Perfect. This is nothing but some steps that you'll have to memorize. Okay, I'll be writing on the code. So here I can say infix to postfix, and we'll be taking a string. What do we need? We definitely need a I equal to 0. We definitely need a stack which is empty, and we definitely need an answer which is initially storing nothing. Perfect. After that, I'll be going on till I don't get till the size of the string that is given to me. I know one thing for sure. If this is an operand, if this is an operand, yeah. If this is an operand, which means S of I has to be greater than capital A and S of I has to be lesser than capital Z. That's if it is in caps. That's one of the conditions. You know about it, right? If this is an opening bracket. So maybe I can write else if S of I is equal to an opening bracket. That scenario, we'll have to do something. Let's check it out. If it is a closing bracket, in that scenario, please keep popping out. Yes, please keep out. I'm going to add it to the answer. At the same time, I'm going to delete it from the stack as well. Done. So whenever I get an opening bracket, I stop. So at the end of the day, please make sure to pop out the opening bracket. So that this is smaller than, take out what you can. At the end of the day, you can do the answer. And this will be nothing but your post a big O of one operation. This is another big O. Similarly, there is a while loop over here. Throughout the journey, this cannot pop out more than n elements from the stack throughout. Right? If your string is of length of n for the outer while loop, and the inner while loop at the worst possible scenario can take a big O of n. Correct? Similarly with the outer one as x to a postfix expression. So before I move on to the next conversion, I'm very sure you know how to write the priority function. You're going to write an integer function, which is going to return 3 if the character is a power function from right to left. After you've reversed, you have to do an infix to a postfix conversion. There'll be one conditional change that you'll have to do. I'll tell you about that as well. And after, got it? Perfect. So what is the next conversion? It is infix to prefix operation, prefix expression. Prefix expression rather. So it has very simple 3 steps. It's slight twist here and there. The first step is you're going to reverse the given infix. That is from right to left. After you've reversed, you have to do an infix to a postfix conversion. There'll be one conditional change that you'll have to do. I'll tell you about that as well. And after this, what you'll be doing is, whatever answer you get, whatever postfix you get, you're going to reverse that answer. You're going to reverse that answer. Perfect. So what is the first step? The first step is very simple. You basically do a reversal of this. So when I do a reversal of this, what I get is f plus d minus c multiplied with closing bracket b plus a and an opening bracket. So once I've reversed it, you'll have to scan through it and make the closing bracket to an opening bracket and make the opening bracket to a closing bracket. What do I mean by that? This is a closing bracket, so I'll convert it into an opening bracket. This is an opening bracket, I'll convert it into a closing bracket. So done and dusted. Once I'm done and dusted with reversing, what I can do is I can start converting this into a postfix expression under some controlled condition. Remember this, under some controlled conditions. The first one is done. So again, very simple. I operator, I take a stack, and I take an answer variable. You can start iterating. The first one is an operand. The stack will stay empty, and this operand will get added to the answer. The next one is operator gets inserted into the stack, and the answer still stays as f. Operand, you take the operand and you add it to the answer, and the stack still has plus. The next one is an operator, and this is where the controlled conversion comes in. If it is an operand, if it is an operator apart from this one, what you will do is you will straight away insert this. Remember this, you'll straight away insert this. In the previous, like in the infix to postfix, you would have taken this out. Remember why? If I just go back, even if the priority of this one is smaller than equal to, even if it's equal to, you take and then you pop it out. But over here, this will be exactly smaller. I'll show you in the code, but as of now, understand this. If it is not a power one and I get anything which is even similar, just put it into the stack. Similar operator, I'll put it into the stack. Next, the answer will still stay as FD. The next is C, which is an operand, so I add it to this one. So the stack still has this one. After that, I have a multiply with it. So whenever I get a multiply, it has a greater priority, so this goes in. And it still stays as FDC. After that, I have an opening bracket. So anytime you get an opening bracket, you just put it in, and it still stays as FDC. After that, I have a B. So whenever you get a B, you basically take FDCB, and the stack still has minus, plus minus into an opening bracket. Then you have a plus. You have a plus, and this is of a low priority, so this gets in. So FDCB. And after that, you have a A. So if you see an A, what you do is FDCBA, and the stack will still stay as it is. And right after this, you have a closing bracket. Whenever you get a closing bracket, you take out everything that you have till you encounter a opening bracket. So you take it out, and after that, the stack still has this much left with it, and you're done with the iteration. When you're done with the iteration, you basically pop out, and you basically pop out. So this is your controlled postfix expression. And what you do is, so the second step is done. And the third step is to reverse this particular answer. This will be plus, minus, multiplied, and then a plus again, and then A, B, C, D, F. And this is your prefix expression. Got it? So we're writing down the pseudocode. Again, super simple, a function which is going to be infix. So we can start iterating. So when I, so you can do that, and you know what happens in that scenario? Use answer plus equal to S of I. What is the other step? Else if this is not the case, and it is an opening bracket. In that scenario, you ask the stack to push it. Remember? So push it into the stack. What is the other scenario? Else if it is a closing bracket. It can be a closing bracket, right? So you know what to do if it's a closing bracket. You take out everything till you encounter an opening bracket. So be like, while I need to make sure the stack is having elements. Opening bracket. You gotta pop yourself out. Bracket. The while loop will stop, so please make sure you pop it out as well. So that will be it for the closing bracket. I have these three conditions are exactly equivalent to what we did in an infix to a postfix conversion, right? So we're done with the first three conditions. The last one is going to be, what if it is an operator? In that scenario, I said we'll do a conditional stuff. It's going to be if the operator is a power one. In that scenario, you're going to always take out anything which has a priority similar to it. There's a priority similar or greater than it. Okay, so what you'll do is you'll say, while the stack is not empty, so the stack has elements, and the priority of my current element is smaller than equal to the priority of the st.top element. So you're going to take this, and I'm going to say, please add it to the answer. So basically what I'm saying is, you cannot store two powers in a stack together. That's what I'm doing. Perfect, done. So this was for greater. This is for power. What if it's not a power? In that scenario, you'll come to this particular else. I like the exact same thing. Okay, A, if the stack is not empty, that means it has elements. And if it has elements, if the priority of my current element is smaller than the priority of st.top in that scenario, only in that scenario, for equal priority of a greater priority, you push it in. For that scenario, you take it off and you add it to your answer. At the same time, you say stack.pop. This will do with the else. So either this while loop or this while loop, controlled conversion. And once the conversion is done, you can take that element because you've done the removals. You can take that element and you can push it into the stack. That would be done with the else part. And after this, you can do I++ and the while loop can be completed. And right at the end, you got to check if the stack still has elements. If the stack still has elements, you're going to do answer plus equal to stack.top, and you're going to do stack.pop. Perfect. Done and dusted. Are we? No. Right at the end, please make sure answer equal to reverse of answer. And once this is done, you could return this particular answer. Done. Please make sure to do one thing. For the first time, when you do a reverse, just don't reverse. Convert the brackets into the opposite as well. Time to talk about the time complexity. This reverse is going to take me a big O of n. I can do a reversal in big O of n. Okay. A big O of n by 2 if you apply your brains. This is going to take me a big O of n. Now this internally, or this internally, or this internally at the worst possible case. Throughout is going to take me a big O of n throughout. Okay. And then I'm again doing a reverse. So I have to compute the overall time complexity. That's a big O of n by 2 for a reverse, a big O of n by 2 for the end reverse, and then a big O of 2n for the stack iteration. So that's near about a big O of 3n, which is as good as big O of n. What about the space complexity? Again, I'm using a stack which can end up storing all the elements. So big O of n complexity. Remember, you can reverse in big O of n by 2. Yeah. Go back to my earlier lectures, you know how to do it. Done and dusted. So that will be it for your infix to prefix conversion. So the next conversion that I will be doing is postfix to the infix expression. So to be given a postfix expression and the same format, I'll be taking an iterator I, but this time I'll be taking a stack, not an answer variable. So I'll be starting off with the first, like the 0th index element, it's an operand. Remember, whenever you encounter an operand, push it into the stack. Perfect. After that, I again encounter an operand. Again, push it into the stack. After that, I encounter an operator. Very critical. Whenever you encounter an operator, you pick up the last two elements from the stack. So you get something B and a A. And whatever is the operator, you put it in between them. And after this, you wrap it up around wrap it up around the bracket, and you put it back into the stack. So now the stack will have a minus b together. Remember this? It will have a minus b together wrapped up around a bracket. After that, I get a d. So I get a d. It's an operand. So what I'll do is the stack still has a minus b. After that, it will have d. After that, again I have a e. So this time I'll put it into the stack. So it will be a minus b, comma d, comma e is what the stack will have. Like these three elements will be there in the stack. It is d will go out, e will go out. I have a f. So whenever you have a multiply, it's an operator. So what you'll do is you'll pick up this, which is e, wrap it around. It's going to be a postfix. Very basic. If it is an operator, should be the operator plus plus plus. But over here it is stated that you're given a valid postfix expression. So this algorithm is going to work. So I have to figure out the time complexity. We have a specifically C is being done in a BGO of 1. Now you might argue we're doing addition operators over here, and the top, like the top element that you're getting from the stack, this is nothing but a string because you're keeping strings in the stack, and the top one is also a string. So this operation might, because when you add strings, it does take time. In some programming languages, addition of two strings can take n1 plus n2, where n1 is the length of the first string and n2 is the length of the second string. So it might end up taking some time. So this is an additional thing that you'll have to mention it to the interviewer. So the time complexity will be big of n for the while loop, and the worst possible scenario because you're adding up strings, and there will be a point where you add up all the strings. So at the worst possible scenario, that can go up to big of n. Again, language specific. What about the space complexity? The space complexity will be big of n because I'm storing all the characters in a stack till the end. That will be the time complexity and the space complexity, and that will be it for this one. So the next conversion that I will be doing is a prefix expression to an infix expression. Again, given a valid prefix expression. So the same format we will follow, an iterator and a stack. The difference is this time will be we'll be iterating from the back, and whenever we get an operand, we put it into the stack. After that, we get to the next one. Again, an operand, we put it back into the stack. After that, we get an operator. After that, we get an operator. This time, what you will do is you'll get the first top and then the second top, and then put the operator in between, surround it with a bracket, second top. So you can do a while I 32. Sorry, that's it. What about the time complexity? Again, strings and can go up to that length. Is given a postfix expression, we'll have to convert that into a prefix expression. Again, you'll be given a valid postfix expression. So this is the one that we'll try to convert. Again, similar tactics. We're going to take an iterator. We're going to take a stack. And this time we start with left to right. What about the space complexity? It's going to be somewhere around big of n because I'm going to store the entire string along with some brackets in the stack. So this will be the overall time complexity and space complexity for a prefix to an infix conversion. So the next conversion that we will be doing is given a postfix expression, we'll have to convert that into a prefix expression. Again, you'll be given a valid postfix expression. So this is the one that we'll try to convert. Again, similar tactics. We're going to take an iterator. We're going to take a stack. And this time we start with left to right. So it has a. So whenever we see an operand, just put it into the stack. Whenever we see an operand, we just put it into a stack. Whenever we see an operator, now over here this is going to be slightly different. Whenever we see an operator, we take that operator, top 2, top 1, and we put that back into the stack. So typically the operator, and then top 2, and then this. This is the overall string that you put back into the stack. Overall string. Don't surround it with brackets. After that, again, we see an operand. So whenever we see an operand, we put it back into the stack. Again, we see an operand. So please make sure you put it back into the stack. After that, we see an operator. Again, you see an operator.
Right, so like I was thinking, so convert it to postfix form. This is a prefix and we need to convert it to postfix. So go from here, add to stack, add to stack, add to stack. The moment you see this, you convert it into postfix instead. Let's try that. I'll copy this and I'm gonna paste. Right, so we're gonna go from right to left. Let's see. Oh god. Okay, this tag is L means LK. It's LKA, and then I see bracket, so it becomes slash of this A slash K becomes And to convert a prefix into postfix, right? AK slash. Comes AK slash. And then AK slash. Right. So minus, so it comes. AK and minus. You put that into the stack. And you put on C, B, UC slash. Or BC slash. C and A. And minus ABC slash AK. Yeah, that's exactly it. I- So basically, I'm just using the basic rule that prefix means operator, operand, operand. Postfix means uh, operator, operand, operand, operator. Right. So we're gonna start from the other end of the string. So it's for int I equal to 3x length minus 1. I is greater than equal to 0. I plus plus. Right. So you just a second. I am back. Hi back. Start from back. You get a stack string st, and then you push it in st dot push 3x I. No, so there's rules to this, right? If is operator char ch equal to 3x I. If it's an operator, then what you got to do is string s1 equal to su dot pop top su dot pop string s2 equal to su dot top su dot pop, and then su dot push um s1 plus s2 plus ch. All right, else that means it's an operand and you just su dot push. ch. And then you push back and goes to right. Girl singing hallelujah. Girl singing. Right, I need to find his operator. Oh, private bool is operator. It's gonna create a set. Operators. What are the operators? It's this um, plus minus divide star exponential plus minus divide star. Is it right? Operators count ch. Because 0 is a false value, 1 is a truthy value. Push ch is convert character to string cb. Right, I forgot. String 1 ch. I hope I'll not convert this to. I got a seg fault. How did I get a seg fault? After I got the correct answer. Man, it's a stack of string and then char ch equal to pre-expression I is greater than or equal to 0. Ah, yes, I need to go minus minus, not plus plus. How did I get a green light there? Right? That should work. And it did work, so that's nice. Similarly, get this. What is the time complexity of character string concatenation in CBV. It's gonna answer that. While it answers that, I'm just gonna go and practice it on GOG. Postfix to prefix conversion. Postfix to prefix conversion. Right. So basically, what postfix does is left, right, and then the operator, right? And you just need to take the moment you find it, you're gonna take BC and then C and slash BC3 watching. Can we get someone in chat? Right, can we get someone in chat? Guys who's watching, get the chat going. So it's gonna be converted into BC slash ones, but I feel like I'm not actually problem solving right here. I need to. The idea is pretty simple. Postfix is operand, operator. Prefix is operator, operand. So it's operand, operator, to operator, operand, and then operator. Right, I think the solution is gonna be pretty similar. It's just right. So I'm just gonna copy this example. The intuition is here is pretty simple. Right. So you just push it onto the stack, push this, and then I'm just gonna take push this. Okay. Push this, and then you push this, and then you push this, and when you see an operator, convert this into a pop slash BC, and you push this entire thing into the stack. You see another one minus, so it's slash BC A and then minus. And you keep going like that, so it's A slash AK and then L minus slash AK AKL, and there's a star minus A slash BC. Is that the answer? Star minus A slash BC minus slash AKL. Right. It's pretty fucking simple. So again, create a new set of characters. An unordered set is fine. Operators is equal to well, right. For int I will 0, I is less than post expression dot length, and then you go I plus plus, and right from here, what you will do is check if operators dot count ch, that is it's an operator, then you do something else, or else you just push ch and then move on to the next one. Create a new stack of string for st. Right, convert the character into string, so it's gonna be string one ch. Congratulations. And then char ch equal to post expression I. If it's an operator, then well, string s1 equal to sc dot top, sc dot pop, and then weird thing, and then string s2 is equal to the same thing. Pop it again, and then c dot push. It's the operator, so that's ch plus um the order pretty much remains the same. S2 plus S1, and then you return the stack top. Waiting for something to break. It did not break. Submit the answer. And 1050. The last one had 21 cases. Why do you have so many cases for this? Postfix to infix. I think I'll do that tomorrow because so that I can rub the entire concept inside my little chubby brain. And for now, let's do one of these. I haven't done a binary search question in so many days. So many fucking days. Binary search on 2DR is and the row minimum ones, isn't it maximum ones? Maximum ones or minimum ones. That's weird. So does LeetCode have maximum ones? Given an m by n where binary matrix has a zero indexed position of the row and contains the maximum count of ones, the number of ones in that row. In case there are multiple rows that have a maximum count of ones, the row with the smallest row number should be selected. Return an array containing index of the row and the number of ones in it. Right, and what's the question right here? Underground with n and then as although sorting or something value. So is to find the index of the row with the maximum number of ones. If two rows and one, there is no. I think the question is similar. I'm going to do it on LeetCode because I love LeetCode. Right. So that's the matrix 0 and 1. Both rows are the same number of 1. So we turn the index of the smaller row 1. Binary. So it's an m by n matrix, obviously. Let's just find out, like, get that out of the way. Rows equal to man dot size, and then int calls equal to man 0 dot size. Now we've got the rows and columns. Right. How do you apply binary search on this? Are these sorted? They're not sorted. Can't do binary search on a row that's not sorted. I need to sort the fucking row. Why is the row not sorted, bro? It's either 0 or it's 1. N is equal to matrix error length. M in live between 1 and 100. Might ij is equal to 1 or 0. If it was sorted, then I could have just applied binary search on it. Right? So if it's 0, 0, 0. Check the middle index. Is it 0? Bro, why is it 0? Middle index here. Is it 1? And then this one's. So we can do something like that. Mm-hmm. But if I start sorting all of them, then I get log n, n log n, n log n, n log n, n log n, m into n log n. That's the time complexity of n log n. Oh god. Right, a time complexity of n log n for one row, and there's n rows. So that's m into n log n. And then I'm gonna fucking binary search on that. So that's like going to log n again. It's gonna be square time complexity. Can't do that. Can't afford that. So you don't expose the row that maximum count of ones, the number of ones that row. So count of ones in that row can be said to be um, okay, I check that. I want to take a look at the hint. 9 online. Number of them. 0 index position of the row that contains the maximum count of ones and the number of ones in that row. So the brute force to this, let's at least get the brute force out of the way. I is less than rows and I plus plus for int j equal to 0, j is less than rows, j plus plus. Right, so int count equal to 0, and if that I j is equal to 1, then count should, if count greater than max count, not you turn a vector and right on 0, index of the row and then number of ones in it. if count is greater than max count is equal to I and max count then you count max count. So that is the naive brute force solution. Bro, someone is consistently watching you with me. It's crazy. It's probably my sister. She said she's gonna watch me. Did you mean Rose? I didn't mean Rose. Thank you. That's actually calls. That works. That's a brute force solution. Why is that 100%? Oh God. Iterate to each run, keep the count of ones. Obviously, I'll do that. I'm just here to say hashtag free. Oh God. This is an apolitical channel. An apolitical or apolitical channel. I don't know. Something to do with the sound of apolitical. Android says count equal to zero. That's the basic solution. Uh, no, that's not okay. See, the thing is, it should be sorted. Right, that's what I'm saying. I could do that, but it's not. It's not the row with maximum ones. If I find it on GFG. Row with max ones practice. You're gonna do the array of 1 0 0 of arrays sorted in an increasing order. Right, right. Sorted in an increasing order. The task is to find and return the index of the first row that contains the maximum number of ones. Now that is the question. Right, non-integrated zeros and ones sorted in ascending order. Find the index of the row. Lower bound, upper bound, find first. Lower bound. Forgot lower bound and upper bound, honestly. But well, right. So 0, 1, 2, 3. 3 by 2 is 0, 1. Is it 1? It is. Well then, 0% by 2 is 0. I'm getting sleepy. I'm getting very sleepy. What's the time? It's 11:23. No wonder I'm getting sleepy. Man. And it's an easy question. Okay, the limit of two solid arrays. Oh, okay. Hmm. I don't wanna do another question. My back hurts. I think this is a win for today. Solve three questions though. I did save this to my sheet. Very easy. Got it. So I'm gonna end the stream and I'm gonna fall asleep. So I'm getting very sleepy. Alright, thanks for tuning in, guys. I'm gonna close the stream now.